Hi, welcome to FPV Flight Airborne. Today I'm going to cover tricopters and some tips that I've learned since I started flying them. I have my little trusty assistant with me, so I'm going to be talking about a couple components on here, try to show you the best of my ability, and hopefully it'll get you a head start when you start the hobby. Alright, so I know I'm not trying to insult anybody's intelligence or anything, but some people really don't know this stuff until they unfortunately figure it out on their own when their tricopter crashes. So, alright, the first thing I'm going to cover is propellers. With a tricopter, the benefit is you can have all the propellers spinning the same direction, so all clockwise propellers or all counterclockwise propellers. And the difference between a clockwise and a counterclockwise propeller is a clockwise propeller and a counterclockwise propeller will almost give away which way that it's spinning. I could tell by just looking at the front of this propeller which way that it's spinning. If this is the curvature of the prop here, this is a 10 by 4.5 prop, then that means it's probably going to spin that way because the drop off of the propeller is actually right here at this point. So that would tell me it's going to spin this way. And if I look at the front of it, the side that basically you can tell the front from the curvature right in the front here, you can pretty much tell which way the front is, or with other props you'll actually see writing on them. That's pretty much a dead giveaway that that's the front of the prop. Now just looking at this one, I can tell that this is a counterclockwise rotating prop as I'm looking at it because it's going to spin. I know this looks clockwise, but for me it looks counterclockwise. It's actually a counterclockwise rotating prop. Same thing for a prop, a clockwise rotating prop. It'll pretty much give it away as you look down at the top of it if you just set it down on the table. Alright, so that's a benefit of having a tricopter. You can't have you can pretty much have the props any way that you want, really, as long as the tail section of the tricopter, the yaw mechanism, compensates for the spin, the directional spin of the motors. So if all of them are spinning one direction, then the tricopter is going to want to spin that same direction. So if they're all counterclockwise rotating props, it's probably going to want to spin to the left. So to counter that, you want to pull it back to the right. What I mean is when you put your servo on, you're going to want to push it back. This is actually so basically to the right. Alright, to basically you want to pull it that way, okay? So it's going to want to turn right, okay? Just like that. As you can see, everything's pretty much backwards, but you get the point. Alright, motor wires. Okay, so another thing with tricopters is the direction of the motors. Some ESCs will pretty much tell you which way that they're going to spin, and basically there's the three color wires. There's red, yellow, and let me show you on a regular motor. So you got your red, yellow, and it's not the same way with all of them, and black. Okay, so that's your control wire, positive, and your negative. All right, if by simply switching the yellow, the control wire, and the red wire, the power wire, the positive, it's going to reverse the direction of the spin. If you put everything on there the same way, so red to red, so positive to positive, black, so ground to ground, and the control wire to control wire, it's going to spin clockwise. That doesn't always sit the same with every motor, but that's a pretty good indicator. And if your prop's spinning the wrong way, then simply switch your wires, and it'll spin the way that you desire for it to spin. Now it's always good to have the two props in the front spinning toward each other, so inward and toward the center, so that the only compensation factor is the one in the back. Now on the KK2 board, it'll have you spinning it clockwise, and if that's the case, then you'll throw a clockwise rotating prop on there. The front left one, for me as I'm looking at it, the front left will be on this side, and I'll also have that one spinning clockwise, and I'll have this one spinning counterclockwise. That just takes a little of the effort of trimming it out. That doesn't have anything to do with anything else. I've tried it every different way, and I've had success in every way. So it doesn't matter which props that you put on. In my opinion, it just takes a little bit more tinkering with. Okay, so next thing I'm going to talk about. Okay, so how do I know on the ESC which one's positive, negative, and control? Okay, not every ESC will have that and just pretty much tell you which positive, negative, and all that. Okay, you're going to get an A, B, C, something like that. Alright, it's going to look like that. So if I want to guess, I guess just a shot in the dark, which one's going to be positive, I'm going to guess it's that one because it's right in line with the one right across from it, and the top one is probably the negative because it's right in line with the negative, and this one's probably the control wire, the one that's in the middle there. And that's how I just start off with that. I don't use props when I test anything, but I'll just start out with that as just a kind of a guess, just to figure out how close I am. Alright, servo controls, negative 100, reverse, positive 100, and reversing in the remote. Okay, so you'll set up your KK2 board just like you do online, and they're going to give you all these tutorials and you're going to see all these things. First of all, you have to follow the version of software that, if I say that I'm covering Stevie's 1.9, then I'm covering Stevie's 1.9. If you get on a website, you can't just assume that KK 2.1 19 or 1.8. Okay, they're all going to have different settings. They're all going to have different things. So negative 100 will reverse the direction of your servo, and positive 100 is the setting that's already in the KK2 board when you turn it on. If your servo's going the wrong direction, as you've seen probably in previous YouTube videos, if you've done some homework, then you'll know that most digital servos are good with the positive 100, and analog servos are good with the negative 100. But you'll find that if you use the analog servo negative 100, sometimes it'll spin out of control. So what I've done to counter that and figure out why it's doing that, I don't really understand why, but if I reverse the direction in my remote, and then I reverse the direction on the KK2 board and make it positive 100 for an analog servo, and reverse my fourth channel, or if I'm using the Stevie's 1.9, which I currently have, then you can use the seventh set of pins there, so the seventh channel, and yeah, it's gonna basically make it stop spinning out of control. If it just spins like a top for no reason and you don't understand why, that's probably what it is, and you need to flip-flop both of those. Do a reverse in your remote and reverse what you normally would do with your analog or your digital servo. I was actually having a problem with my digital servo. When I went to negative 100, it was going the right direction, but it was just so overly sensitive that it would just rip my tricopter and start spinning around in circles. And I figured out that's how I combated that. Alright, self-level. Okay, so self-level, in my opinion, I don't use self-level. I think that self-level is a great feature. It's, in my opinion, I think it would be a good use to know your throttle settings. So mine's at 55% for a hover on my sticks. I use 30% expos on everything. So 55%, it's pretty good for the weight that I have. I'm comfortable with it, and I know that if I hit my my switch to put it in a self level, then it will. If I take it down like right below 55%, between 50 to 55, it's gonna slowly descend down to the ground evenly if I lose contact to the aircraft, and I know that it'll land somewhere, but safely, and not into somebody's house or anything crazy. I mean, you shouldn't be flying over populated areas anyway, but it'll at least bring the tricopter down to the ground nice and level if you have your self-level settings correct and everything's good. And that's what I think good self-level is good for. Or when you're trying to get some stable video from possibly like a high alpha situation, you're just trying to pick up a sunset or whatever you're trying to do, then that'll help you. Alright, so how to adjust self-level settings. Well, there's about 1 million tutorials on how to adjust self-level settings, and I wrote this down so that you really just need to play with it with the KK2 board. Don't just take anybody's tutorial and just do it. You'll need to make sure that you actually adjust it by yourself. Make large corrections, write down what they are, because they may be different for your setup. Tricopter specific, if you, from my experience, if you go negative, what I mean by that is if I take away and go into the negatives of my self-level settings, my aileron, so channel 1, it's gonna make my tricopter bank to its left. If I give it positive correction, it's gonna make it bank to the right. If I give it negative correction, it's gonna make it lean back, and positive, it's gonna make it lean forward. And my yaw correction should be done in the mode settings and underneath, all the way down to the bottom and under offset. Alright, so yaw mechanisms. There's about 1 million of them out there, and not one is going to suit your needs. So just be mindful of the fact that there are 1 million yaw mechanisms out there, and the only really good way to get a good yaw mechanism is to just try out multiple yaw mechanisms. Honestly, like I've tried 2 or 3 different yaw mechanisms, and the one that I found that was the best was from David Winstall from rcexplorer.se. And at RC Explorer, the tricopter is just, it's amazing. I haven't used it, but I've watched so many videos and I've seen people fly it, and it's a great tricopter. It really is. The yaw mechanism is amazing. I use it for my self-built tricopter, and it works fantastic. T-copter versus tricopter. So T-copters are great, and I really like them because they get the propellers out of the picture. If you're using, if you built your own tricopter, or you thought about building your own tricopter, I wouldn't say T-copter's great or not great. It's kind of just what you want to do. A T-copter is going to make you lean forward a lot. So if you give it forward input, it's not so spread out and based out like a tricopter is, because a tricopter isn't going to have its arms straight out in front of it completely. Yeah, you may end up having a propeller in the video, but it's also much more stable, in my opinion, than a T-copter. Now, stability, yeah, it may be the same when it's in a hover or something similar, but descending, tricopter is definitely more stable, and also forward flight, flying sideways, backwards, it's more stable. Flight tips, okay. Learn to fly in manual mode. Alright, so that's like the first thing. Make sure that you hover on the ground before you actually try to hover. What that means is, see which side is going up and down while it's on the ground. Don't just hop right into it and pop it off the ground like I'm about to tell you. So after you get done with understanding what controls do what, I think that basic fundamental is not really talked about. I think that kind of gets overlooked. You just really need to understand the functionality of it if you've never flown any type of multi-rotor or aircraft before, like RC aircraft. Alright, and then so once you get decent at that, you'll want to get it off the ground. You don't want to have your tricopter close to the ground, because you're going to get a lot of rotor wash. You're going to have dirty air down there, so you're not going to be able to trim your tricopter that really close to the ground. You're going to think that everything's just way off, and you'll be sitting there making correction after correction, but it's really just bad air when you're really close to the ground. So get it up about 3 to 4 feet into a hover, maybe even a little bit higher, and make your corrections after land, and then make your corrections. But pop it up off the ground. Give it, if I'm going 55% throttle, maybe push it a little bit harder, and get it up to maybe 65-70% throttle, just to get it off the ground, and then you can make your corrections from there. If everything's set up correctly, you shouldn't really have too many problems. Just make sure you trim it on the ground. Like I said, do all the little minute corrections on the ground, see which side's lifting up more than another, and then make the corrections on the KK2 board, and not in your, if you can, and then go to your controller. So if your yaw mechanism's acting crazy, adjust your yaw and the offset and under mode settings. Now I'm going to go ahead and go into the next one. So then hover, alright, so once you get your corrections pretty close, you'll pop it off the ground and then hold a hover. Once you get the hover down, you're going to hover. Alright, the next thing that you learn after you hover with the rear end of the aircraft facing toward you, then you're going to go straight, you're going to basically fly forward and then fly back toward yourself. So fly forward, slow down, and then fly back, and then fly forward and then fly back like this. So it should be basically you slowing yourself down just like this. So you'll fly forward for a little bit and then slow it down and then bring it to hover and then fly back again, and then you're obviously going to be tilting down this way, so you're going to have to slow it down and then bring it back to hover, and keep doing that back and forth until you get that down and you're comfortable. Alright, so then after you're done with that, you're going to hover and then turn left and right and hold your hover. So you'll want to have the aircraft come to a regular hover and then turn left and hold that hover just like that, and it'll probably be swaying, going back and forth. It's going to make you have to think and try to figure out why, which way it's doing this and that, and get comfortable with that hover, and then do the same thing facing the other direction just like that. And once you get comfortable with that, then you're going to go into and turn around, and you're actually going to face yourself. So you're going to get the tricopter up to a hover and turn it around facing toward yourself just like that, and then you're going to be able to, once you get comfortable with that hover there, then you'll be able to transition between all the directions. Alright, and after you get comfortable with transitioning left, right, back, forward, facing me, facing away, then you'll be able to actually continue and actually do a circle. So you'll start from you with the rear end facing toward you, turn left, fly straight, and do a bank into a turn, and start getting comfortable with turning eventually. Okay, so you're gonna have to start banking, or you're just gonna drift off. And if you don't actually use your roll support, so your easy stick movement to be able to transition and turn back around and fly back the other way, then you won't be able to effectively do a circle without losing control of your aircraft at every turn. Alright, so once you get comfortable with that, you'll want to do it the other way. So counterclockwise, you'll do clockwise, then counterclockwise, and keep doing that until you get really comfortable, and then fly like that for an extremely long time until you actually start going into doing flips